In this video, we will discuss the common trig angles. This is something that is absolutely essential for you to know for your calculus sequence. The values of the trig functions, specifically sine and cosine, at these common angles, 0, pi over 6, pi over 4, pi over 3, pi over 2, and then even multiples of that around the unit circle. Now, let's see what portions of this table are easy to fill in if we remember how the unit circle works. So, for the unit circle, and I'll just sketch the top half of it here. Call it a circle of radius 1 centered at the origin. Now, the important thing to note here is that if we consider a point on this unit circle and then look at the angle formed coming from the positive x-axis in the counterclockwise direction to give you that point will have coordinates given by cosine of the angle theta, sine of the angle theta. So for example, if that angle is 0, that puts us at the point 1, 0. So that would give us cosine 0, sine 0. So we know that sine of 0 is 0, and cosine of 0 is 1. If we make that angle pi over 2, we know that 0, 1 is equal to cosine pi over 2 sine pi over 2. So that sine of pi over 2 is a number 1, cosine of pi over 2 is a number 0. And then if we think of making the angle pi over 4, that puts us on, say, the line y equals x. So pi over 4 is going to correspond to the angle where cosine and sine are equal to each other. So just note cosine pi over 4 equals sine pi over 4, and both of those are equal to square root 2 over 2. And for this reason, I find that students are typically much better at remembering what happens at the angles of 0, pi over 4, and pi over 2. We can just think of our unit circle. Now, what's happening at pi over 6 and what's happening at pi over 3 is typically where we need to think a little bit harder. And what I find is that students usually remember what the possible values are. It's just pairing them up. So we know that these are going to end up being 1/2 or root 3 over 2 from our experience. The question just comes down to which one is which. And I have 3 methods here that might help you to remember this. The first method is to use the 30, 60, 90 triangle. So if I draw out here the 30, 60, 90 triangle, so we have our angle 30, our angle 60. We know that the side lengths of this triangle should be labeled with 1, square root 3, and 2. And just remember that the largest side length will be across from the largest angle. So the hypotenuse is 2. The smallest side length is across from the smallest angle, which allows us to label those remaining legs. Now, looking at what we have here, well, we can see that cosine of pi over 6, so pi over 6 is 30 degrees, is root 3 over 2, and sine pi over 6 is 1/2. If we look at 60 degrees, we can see that sine of pi over 3 is root 3 over 2, and cosine pi over 3 is 1/2. So if you remember your 30, 60, 90 triangle, it's a matter of labeling the sides correctly, and then we can use how the trig functions are defined to remember cosine and sine of pi over 6, pi over 3. That can be really useful is to just think about what sine and cosine look like graphically. So if we consider sine, and let's just look at what's going on here from 0 to pi over 2, roughly speaking, it's going to look something like this. If we look at cosine, once again from 0 to pi over 2, it will look something like this. And now, recall what we're trying to determine. Sine of what angle is going to be 1/2? Sine of what angle is going to be root 3 over 2? Well, looking at the graph of sine, we see from 0 to pi over 2 it's increasing. So the smaller value is going to occur at the smaller angle, which means it will be pi over 6 as an input. That gives us 1/2 as an output. And the larger input, pi over 3, gives us out root 3 over 2. Similarly here for cosine, it is decreasing on the interval from 0 to pi over 2. So the smaller value of 1/2 is going to occur for a larger input. So it is cosine of pi over 3, which is 1/2, and cosine pi over 6, which is root 3 over 2. A third use for these trig functions is to make a table. And there's a pattern here. So if we go sine cosine, and we're going from 0, pi over 6, pi over 4, pi over 3, pi over 2. So we're going to say sine of 0 is square root 0 over 2, which note is just another way of writing 0. Then pi over 6 will be square root 1 over 2, which is just a fancy way of writing 1/2. Then square root 2 over 2, square root 3 over 2, square root 4 over 2. A nice pattern. Where, of course, square root 4 over 2 is just 1. Then for cosine theta, you just reverse that pattern. Square root 4 over 2, square root 3 over 2, square root 2 over 2, square root 1 over 2, square root 0 over 2. And the key here is to realize you need just one way that allows you to remember the values of these trig functions. So pick the way that makes most sense to you.